So now that we know what the molecular equation is, now that we've written the complete ionic, where every ion is written the way that it would be in actual solution, so now I can see those actual dissolved species. These would be breaking apart. This would stay together. The next thing I want to talk about is the net ionic equation. But before I can talk about the net ionic equation, I have to introduce one definition. So this is going to be what we call spectator ions. So spectator ions are ions that are both reactants and products. So we give the name because they're spectating. They're not doing anything. They're not reacting. They're just kind of there. So these are going to be ions that are on both sides of my reaction. So if I look here, I want to find an ion that's on both sides. And it needs to be written the exact same. So the first one I have is 2K plus aqueous. Do I have any other 2K plus aqueuses? I do. So here's one, and here's one. So they're written on both sides. This ion is both a reactant and a product. It's not actually doing anything. It's there at the beginning, it's there at the end. It's just spectating. What about the OH minus? Here's OH minus, but here's OH in a compound, so no. Mg2 plus, Mg as a compound, so no. 2NO3 minus aqueous, 2NO3 minus aqueous. So these are my spectator ions. So if I asked you what are the spectator ions, you would say K plus aqueous is a spectator and NO3 minus aqueous are spectators. So those are the ones that are just sitting around not doing anything. So now that I know what are spectator ions, now I can write my net ionic equation. So the net ionic equation is an ionic equation in which the spectator ions are removed. This shows who is actually reacting. So if I remove the spectator ions, now I know, well, who's actually reacting? Who's actually participating in what I'm doing? So what I would do is I would go here and I would just take out every one that's a spectator and write only what's left. So if I write what's left, I would have 2 OH minus AQ. So this goes away, 2 OH minus AQ, 1 Mg2 plus AQ. You don't have to write the 1 because it's understood. So Mg2 plus AQ, that goes away, that goes away, that goes away, and then my MgOH2. And it should be balanced. 2 OHs, 2 OHs, 1 Mg, 1 Mg. Okay, so if it's not balanced at this point, then you balanced it incorrectly when you are writing your complete ionic equation, because it should stay balanced. Now, sometimes what might happen is your coefficients are like a multiple, so you might get something where it's like 4, 2, and 2. So if your coefficients are 4, 2, and 2, then you would want to reduce them. So this would go down to 1, 1, and 2. So if you do get something like that, where it's still balanced, you just want to reduce your coefficients. So this would be the net ionic equation. So what this is telling me is that these guys were just hanging out, they weren't doing anything. Really, the OH minus was reacting with the Mg to make my precipitate. So that's what was actually happening in my reaction. All right, so now we know how to write net ionic equations, complete ionic equations, because so far all we've talked about are molecular equations. So before we talk about another type of reaction besides precipitation reactions, the next one we're going to talk about are acid-base reactions. We need to talk about acids and bases in more detail. Okay? So on the rest of this little section, we're gonna start diving into acids and bases a little bit more, and then talk about another type of reaction that's based on acids and bases.